Okay, so for this circuit, we have to find we have to find VO. So we're given the equation for this voltage source. We can tell that VO will be the difference in voltage from here to here, and since this is the ground node, that means this should be VO, and that means this whole region will be VO. Okay, so this whole region will be VO. So what we can do is try and combine these two values together. So let's find their impedance. So this one, its impedance value will be 1 over JWC. So 1 over J, W is 4. And then 10 divided by 1,000, that's 0.01. So its impedance value will be 0.01 times 4. So that's 0.04. And then 1 over all of that, that's 25. And then we can bring the j to the top by timesing the top and bottom by j. So it'll be negative 25j. So that's the impedance value here. Now let's find the impedance value for this inductor. So it'll be JWL. So it'll be J4, 5. So that's 20. That's the impedance value for the inductor, J20. Anyways, now so pretty much if we can combine these two impedance values into one, then we can quickly use voltage division to find VO, because obviously afterwards our circuit will be confined to this region, but we know that this region will be VO, so that means the voltage at this between the voltage between here will also be VO. So let's try and find the impedance value if we were to combine these two. So since they're in parallel, it'll be 1 over minus 25j plus 1 over j20 to the power of minus 1. Using your calculator, by putting it on imaginary mode, you should get the following value. So just give me a quick second. Okay, so you should get 100j. So we can rewrite the circuit like as the following. This will be 100j, 60 ohms. Oh yeah, the impedance for the resistor, it's also going to be 60 ohms. And I'm not going to write that equation yet. Okay, now the voltage at this region, VO, that's what we're trying to look for. Where did that go? Okay, whatever, I'll just use a different color, VO. And the voltage of VO will be the same as the voltage here, okay? So we know the voltage source is represented by 20 cos 4t minus 15. All right. So what we'll do, we'll turn this into a phasor format, which will be like this. You put this value in front, and then you put the degree in here. And then let's get our imaginary and complex numbers separate. So to do that, it'll be 20 cos minus 15 plus j 20 sine minus 15. So 20 cos minus 15, that's 19.32 plus 20 sine minus 15, that's minus j 5.176. Okay, so we'll represent our voltage source with this. Okay, so now to find VO, we're just going to do some voltage division. Okay, so it'll be 100j. Since these are in series, it'll be 100j all over 100j plus 60j. So sorry, just 60, my bad. All right, so this on the top, that's what the voltage we're trying to look for. So it goes up here, and then we add up all the other resistors. sorry, all the other impedance values, and then we times it by our voltage source. Okay, so putting all of this in your calculator, you're gonna get a value. So put everything on so it'll be 100 I all over 100 I plus 60 times 19.32 minus 5.176 I, and you get VO to be 16.489 for the real number plus 4.717 J or I, doesn't matter. Now to represent this as a phasor format, we have to find the magnitude of these two. So it'll be 16.489 squared plus 4.717 squared, all to the square root. So let me see what that gives me. That gives me 17.1504. And then let's get our angle. So it'll be tan inverse the imaginary part first, so 4.717 all over the real part, so 16.489. So our degree will be the following. It'll be 15.964 degrees. And then to write it in cos format, it'll just be cos. Then you put so WT plus 15.964, and then W was 4, if you recall from the equation. And this is what VOT will be represented by.